I really love lighting. Wait, hold on. Mainly because of how powerful it can be. Poor lighting can ruin even the coolest looking scene, while good lighting can take something simple and make it interesting. And lighting a scene is a super creative process because it can help define the aesthetic of your game. So in this video, we'll look at how to use lighting to achieve different looks. I'll show you all the tricks I used to light this indoor scene and this outdoor daytime scene, and how you can very quickly turn daytime into nighttime. We'll learn about the technical aspects that go into doing all of this and how to find a balance between performant and high quality lighting. We'll of course also cover global illumination, reflections, and the concept of light baking. So lots of ground to cover, and before we get into how you can get creative with lighting, here's a very quick intro to how lights work in Godot. But first, this video is sponsored by Zenva. If you already know the basics of Godot and want to level up, check out Zenva's Intermediate Godot mini degree. This is a complete learning pathway designed to take your skills to the next stage. You'll dive into key topics like version control, shaders, procedural generation, and best practices in programming patterns. Plus, you'll learn multiplayer development and how to create custom plugins. Zenva's platform makes learning fun and practical, with professional video tutorials, written lessons, and interactive quizzes. With a single subscription, which includes a 7-day free trial, you unlock this entire pathway, plus over 300 other courses on topics like Unity, Python, and Unreal. Use the link below to get 20% off your first year on top of any existing discounts. The offer is only valid for the first 50 subscribers, so don't miss out. Godot has a few different sources of light. The first is obvious. It's the 3D light nodes that we manually place around our scene. But the world environment can also add light to a scene, and so can emissive materials, but we'll get to those. So let's start with this very simple scene. And the question that normally comes up is, how do I get rid of the lighting that is already here? See, by default, Godot uses a preview, sun, and environment when working in the editor. So to make the scene dark, we can disable the preview sun by pressing this icon. But it's still not completely black. This is because the preview environment also contributes light to the scene. So you'd think that we can just disable the preview environment then. But this just makes Godot default to this horrible gray color. Instead, we need to enable the preview environment, go under these 3 dots, and add the environment to our scene. As you can see, we now have a world environment node. Here we can go under environment and set the background mode from sky to custom color. And because the color is set to black, we can see that our scene turns dark. I will also just go under the glow here and disable it. So now our scene is completely dark, which means that we can add a light node to see the effects of that light only. And if you watched our video on making 3D games in Godot, you'll know that we have 3 different light nodes that we can place in our scene. Directional light, which shines light onto the entire scene from a certain direction. It's often used as a sun or moon. Omnilight, which emits light from a point out in a radius. Think of it like a light bulb. And spotlight, which emits a cone of light in the direction it's pointing, kind of like a flashlight. It's pretty easy to start playing around with these lights. Just add one to your scene and place it where you see fit. But there are a few things that are good to know. So here I've added an omnilight to the scene, but the lights actually share a lot of the same properties. For example, if we go under shadow, for all of them we can enable shadows here. We can also go under light and set the energy, which is the intensity of the light, as well as choose a color. But there are also some settings that are specific to each light. For example, under Omni here we can set the range of the light. We can also adjust that with the gizmo. And we can change the attenuation. This controls how light will fall off as we get further from the source. An attenuation of 2 is physically accurate. And right now Godot is emitting light from just a tiny point. We can go ahead and increase the size in order to simulate light coming from a larger source. We can see that this has 2 effects. First of all, the size of the light in the reflections grow, and also it results in shadows becoming softer. Increasing the size of a light can give really nice looking results, but it's very performance heavy, so use it with care. If you find that your shadows are looking fuzzy, you can always go under Project, Project Settings, enable Advanced Settings, and then scroll down to Lights and Shadows. Here we can increase the soft shadow filter quality for both directional and positional shadows. So I'll just set mine to high here, and that should instantly make the shadows look a lot smoother. The spotlight again shares many of the same settings, but for this one we can control the angle, which is kind of the width of the cone, as well as the angle attenuation, which again controls light fall off as we near the edges of the cone. And the directional light is no exception, again many of the same settings, but under directional shadow we can adjust the max distance. This controls how far away we can see the shadows cast by the directional light. This is of course a performance optimization, but if you find that shadows are fading out too close to the camera, you can simply increase the max distance. Now as mentioned, light nodes aren't the only sources of light in Godot. As we saw, the world environment can also add light to our scene. Let's call this environment light. By default, the world environment adds light to our scene based on the background we choose. So since we made the background a solid black, no environment light is currently being added. But if we were to change this to a brighter color, we can see that it hugely influences the light of our scene. And if we set the background to a sky, the colors of our sky now determine the environment light. So modifying the sky again has a big impact on the scene. But of course, we might want to make changes to the background without affecting the light. In this case, we can go under ambient light, which is the constant amount of light being added to the scene, and modify it individually. We can adjust the intensity, or set the source to something completely different from the background. But the environment also contributes another kind of light to the scene. Can you guess what it is? It's visible on the screen right now. That's right, it's reflections. Very reflective materials like this sphere show this pretty clearly. But just slightly reflective materials are also influenced by this. And just like with ambient light, we have individual control over that here. Finally, an important thing to know is that environment light is global. Both ambient and reflected light will affect all geometry of the scene. It doesn't matter if it's indoors or outdoors, nearby or far away. This is sometimes what you want, and sometimes it's not. We'll get into how we can influence that later. Also, I'll be using these guide spheres throughout the video. I find that they make it easier to see if the brightness is good and if reflections are working properly. If you want to do this yourself, it's nothing fancy, just a scene with 3 spheres, each with a standard material. One almost black like coal, one almost white like paper, and one shiny like a mirror. The exact material values for this really aren't important. Alright, now we know some of the tools at our disposal, which means that we can start thinking about how to use them to express ideas. Because lighting is an art form, and one that is just as important in games as it is in theater and movies. And by far, the most important part of lighting is placement. Light shining directly onto a subject from the same height tend to feel less dramatic, while lights shining from either above or below a subject tend to feel more dramatic. In fact, using just one light with the same settings, we can turn something nice and inviting into something dark and dramatic. Alright, I don't do dramatic that well, but you get the idea. And we don't want to focus too much on light, which I realize is a weird thing to say in a video on lighting, but there's another thing that is equally as important: shadows. Here's a monkey lit with a single light and very little shadowing. It looks super bland. And here's the same monkey, lit with the same light, but moved slightly and with heavy shadows. Suddenly we have atmosphere, intrigue, mystery. And you'll probably recognize this from movies. A romantic comedy is usually bright and evenly lit with light soft shadows, and the light color is warm. An action thriller, on the other hand, is usually dark and unevenly lit with heavy hard shadows, and will probably use cooler lights, especially during nighttime. In general, shadows mean mystery. What we cannot see, we might imagine or wonder about. But of course, we can use more than one light, and I find that the best introduction to this is the idea of 3-point lighting. Here we define a key light, which is the main light illuminating the scene. When outdoors during daytime, the key light is almost always the sun, and in a studio environment like this, the key light would be this big frontal light here illuminating my face. In games though, many scenes will have multiple key lights, especially indoor scenes. The key light is often supplemented by a fill light, which softens the contrast by brightening some of the dark areas. For our setup here, we use a less powerful light shining directly onto the shadowed part of my face. It's common in games to use environment light to accomplish this. Finally, a light from behind the subject, called a rim light or backlight, can help define the shape of the subject as well as make it stand out from the background. We also use this here. As you can see, it helps define the shape of my head. It's common for a rim light to be a different color than the rest of the scene. This light here, for example, is set to a much cooler color than the lights in front. So these are the 3 lights that make up 3-point lighting. And while we might not use this setup exactly when lighting a game scene, I think about it all the time when lighting pretty much anything. So let's do exactly that while looking at our first example, lighting this tavern. So because this is an indoor scene, I started by setting the background color of the world environment node to black. I then thought about what light might be spilling in from the outdoors. If it's pitch black outdoors or we're deep underground, I might not use any environment light at all, especially if I'm going for a very dramatic or spooky look. But if it's bright outside, I'll most often set the ambient light source to sky and adjust the parameters to something that feels natural for this setting. In this case, I was going for a nighttime look, but with a little bit of cool moonlight shining through. The default sky was already pretty close, I just toned it down a bit and gave it a blue and purple tint. Next I look for physical lights in the scene. Are there lamps, candles, or other things that might emit light? In this case, the first thing I noticed were the candles on the tables. So I added an omni-light for each. The lights have a low range and a warm color. There are 4 candles, so I made them faster by not enabling shadows, which is fine for lights that are quite subtle. Also, I didn't want the light to spill out too far, so I increased the attenuation to 2. Next, I added an omni-light to the oil lamp. This one is bigger, a bit less warm, and has shadows enabled. It acts kind of like a key light. And I did the same for the furnace, but this one needed a heavy orange color. Notice how I'm placing the lights just above or next to the light source. I find that this often produces the most natural looking results. Another thing that you'll see me doing is going under the world environment and adjusting the exposure as I go. For the example scenes in this video, I used the new AGX tone mapper available in Godot 4.4, with just a little bit of color correction to add some contrast. Now at this point you might be thinking, I can see the effects of the lights, but I can't see the lights themselves. In other words, we need a way to define emissive surfaces that the player can see. And more than this, we don't just want these surfaces to be bright. We need them to glow. In real life, when looking at a light source, we can often see a halo forming around it. This is because light gets scattered by impurities in the air, such as dust and smoke. And when filming with a camera, light is scattered in the lens itself, especially if the glass is dirty. To achieve this in a game, we combine emissive materials with a bit of post-processing. So first, creating an emissive material is actually really easy because it's built into the standard material. Say we wanted to add emission to this box. We would create a standard material, so right-click, create new resource, standard material. I'll name it emissive material. We assign it to the box, and then in the material we can go under emission and enable it. We can set an emission color and adjust the energy. So now the surface is bright, but we need it to actually glow. And for this we use post-processing. So we'll go under the world environment, we'll go under glow and enable the glow effect. And we can start to see something now, but I don't think the default settings here are very good. I almost always change the blend mode from soft light to screen. And we can also increase some of the levels in order to introduce more halos of varying sizes. I often go for something like this. Now this effect takes advantage of HDR to only create glow around very bright spots. And we can adjust how bright a value must be by using the HDR threshold. And now we can freely create and adjust emissive materials and we'll see the effects immediately. But as you might have noticed, emissive materials don't actually emit light onto their surroundings in real time. They have to be combined with a light source such as an omni-light to achieve that. However, there are ways to make it seem like emissive surfaces are actually casting light, which we'll see later. Returning to our tavern, the model actually came with an emission texture. So it was as simple as adding it to the material and setting up the glow effect like we just saw. It's always nice when you have emission textures to work with, but if you don't, a lot of the time you can get away with using a simple mesh with an emissive material on it. I've used this trick a lot. And at this point, this scene looks alright. But something about it feels a bit bland. And I think the reason why is because the colors of the lights and the textures are all very similar. In other words, we need contrast. And also, currently there's only light coming from visible light sources. A great way to add interest to a scene and make it feel like a bigger whole is by allowing light to shine through, say, a doorway, thus making the player wonder what's on the other side. So I decided to take advantage of the staircase leading down by adding a green omnilight to create the impression of something weird and interesting going on in the cellar. I think this instantly makes you wonder what's down there. Is it a lab? Is it magic or monsters? And to further tie the room together with the outside world, I imagined that moonlight was shining in through some windows in the near walls. So I added 2 more omnilights with a dark blue tint to show that. And already this scene is looking pretty good. But we can definitely make this basement light pop even more by using just a little bit of secret sauce. Before we do that though, I thought it would be cool if we took what we've learned so far and used it to light an outdoor scene as well. And what better place to do that than outdoors? For outdoor scenes, I like to begin with the sky, since it has a huge impact on the mood of the scene and will help inform how the scene should be lit. In this case, I decided to use a sky HDRI from Polyhaven. I'll often try out a few different ones to see what works well for the scene. I landed on a warm sunset. If you want to learn more about custom skies and the world environment in general, you can check out our video on making 3D games in Godot. Now, the most important light in a daylight scene is the sun. So I added a directional light. I rotated it around until I thought it created some interesting shadowing and then matched up the angle with the sun on the sky. Because the sun is low in the sky, I also made the light slightly orange. Next, I looked for other light sources.
Would you please? I'm trying to concentrate and you're not making it easy. Alright, guess I won't have any birds in the scene then.
Anyway, next I looked for other light sources in the scene. Since the sun is setting, I thought it was reasonable for the lamps to have been turned on at this time of day. So I added an omnilight to each with a fairly low intensity and a warm color. It's important not to exaggerate these, since the light of the sun should still feel powerful compared to artificial lights. I also enabled shadows. If I was targeting low-end hardware, I would either keep these disabled or bake the lights, but we'll get to that. Finally, I added emission to the lamps. And at this point the scene looks fine, but it feels a little dead. So to give the impression that there are actually people living here, I added emission to some of the windows as well. I also decided to throw in a second directional light to act as a rim light. I made it shine from the opposite direction and gave it a cooler color. This scene also lends itself well to some subtle VFX to simulate particles in the wind or perhaps swaying in the grass, but that's for another video. And the background currently feels very much like a background. It would be great if we could find a way to blend the sky and geometry together a bit more. Which again brings us to that secret sauce I talked about. Fog. Fog is a really helpful tool when lighting a scene. It's great for blending geometry with the background. It can also be used to hide render limitations in the distance and to create all kinds of cool effects. For example, we can use it to fade distant objects into the dark, creating a really claustrophobic effect super common in horror games. Such an effect can be achieved using what I would call old-school fog, which can be found in the World Environment node under Fog. This is a very performant way of fading objects into a solid color based on depth or height. I won't go into all the parameters here, but I recommend you play around with them. They can easily inspire cool looks for your game. To create a horror-like fog, for example, we can set the mode to depth and change the light color to black. Then we can choose where the fog should start fading in using depth begin, and where it should be completely black using depth end. And that's it. When we move the camera through the scene, the fog makes sure that everything that is not close to us fades to black. But Godot also has the option to add volumetric fog. This is a much more realistic fog calculation that will color the fog based on the light shining through it. In other words, it can be used to emulate light being scattered by particles in the air. This is of course also more expensive to render. In our indoor scene, we can use volumetric fog to draw more attention to the staircase by making the light visible when shining through it. To do this, I enabled volumetric fog on the world environment, lowered the density a bit, and set the sky effect to 0. I didn't want to make the fog thicker, but I still didn't think the green light was clear enough, so I selected it and increased the volumetric fog energy for this light only. And voila! The basement now looks like a very interesting place to go. And in our daytime scene, I used fog to better match the geometry with the sky. All I did was add some volumetric fog with a fairly low density and a color that is pretty close to that of the sky. I think it makes the scene feel much more natural.
And if we look at our scenes, I think the results are pretty good. The indoor scene uses a lot of contrast and colors that matches the stylized look of the models, and the outdoor scene relies more on the atmosphere of the sky and the long directional shadows that we soften a bit using a few omnilights. So we could stop here, except by default, all lights in Godot are rendered in real time. This means that the effect of the light is calculated every frame, so if we move it during our game, we can see it updating. But depending on the complexity of your scene, this can get pretty heavy on the graphics card, and while real-time lighting looks pretty good, it can actually get a whole lot better. How? With global illumination. Global illumination, or just GI, is a wide term for a bunch of rendering techniques that all have the goal of simulating more realistic lighting. It's one of the most important parts of making light behave more like we'd expect from real life. Which is of course pretty vague. What does it actually do? Well, on top of the direct lighting that we've seen so far, global illumination aims to add indirect or bounce light. In real life, light bounces between objects. This means that we don't only perceive light coming from an object directly in the light source path. We also see light that has bounced around a bunch before reaching our eyes. The result of this is that light will spill from one object to another, and that it will also assume the color of the surface it bounces off of. In other words, the albedo of the materials in our scene start to affect the lighting. Another effect of this is that shadows become less harsh, because light will bounce around and reach the shadowed areas, making them brighter. The best example of this from real life is probably the sun. The sun is so powerful that even areas in shadow are plenty bright for us to see. And we could simulate this by throwing a big directional light into the scene and then calculating bounce upon bounce upon bounce until light properly spills into all the shadowed areas. But computing all these bounces on bounces can quickly get a little crazy, so realistically we can only calculate a handful. Or, as we often do in rendering, we can cheat. There are many ways to cheat these effects, and they all have their pros and cons. Let's have a look at some of the cheats that are built into Godot for us to use.
The simplest one we've already been using: environment light. This is not a full global illumination technique, but it's used to mimic the bounce light that comes from a very powerful light source, such as a sun in the sky. Environment light is fully real-time and is definitely the easiest way to fake indirect lighting in your scene. However, a problem that you might have already noticed is that the parts of your scene that you want to stay dark aren't. Because again, we're just adding light to everything. Also say the dungeon part of a level. So to get a bit more control, we use the next cheat: reflection probes. With reflection probes, we can change the environment light throughout our scene. A reflection probe renders the scene from the point where it's placed, and uses this to apply ambient and reflected light to geometry within the area that we define. So if the area surrounding the probe is largely in shadow, it will further darken that area. For this, however, we have to make sure to enable shadows on the reflection probe. And if we want an area to not at all be influenced by the ambient light of our sky, we can set the probe to interior. So reflection probes are an easy way to define areas where the environment light should be dependent on the immediate surroundings, such as in a smaller room. And because reflection probes also affect reflected light, they can be used to get way better reflections, hence the name. Reflection probes are highly performant and can be a very simple alternative to proper GI techniques. Which brings us to the real global illumination stuff, which we often use together with environment light to really sell the effect. And which can make emissive materials actually add light to our scene. Achieving good-looking global illumination is particularly difficult for objects and lights that change during the game. Because of this, no matter which GI solution we choose, we need to start thinking about which parts of our scene are static and which we want to move. Normally, meshes in Godot are marked as static. By selecting a mesh and going under global illumination, we can change this. Static is of course used for objects that you're sure will never move, but you'll notice that there are two more options here: disabled, and dynamic. And to make things confusing, if we're using an imported model, we can also set the mode in the import settings under Meshes Light Baking, except here there is a fourth option called Static Light Maps. Lights also have a bake mode that we can set, and the real confusing part is that all of these bake modes, static, dynamic, and so on, will do different things depending on the GI solution we use. So instead of going over every single way that these modes affect the scene using each GI technique and getting more confused than we need to be, let's get an overview of the different GI solutions at your disposal and how you can start using them. And then I'll link to the documentation so you can see how to set the bake modes for the one that you decide to use. So here's a quick comparison between the main GI solutions currently in Godot. Perhaps a pretty overwhelming amount of information here, so let's dive into some examples. First off, we have SDF GI, which is Godot's very plug-and-play approach to global illumination. Its biggest strength is probably how fast it is to work with. Adding SDF GI to a scene is as simple as selecting the world environment, going under SDF GI and checking Enabled. To see it, we'll need to move the camera a bit, and that should do it. There are a lot of settings here that we can adjust, but most importantly, we can set the energy. This will change the brightness of indirect light and reflections. We can also toggle Use Occlusion to reduce light leaking, which is the term for light spilling through geometry that should otherwise be blocking it. This does have a performance cost and can introduce other artifacts, so only use it when necessary. As you can see, SDF GI is really fast to use. There's no baking required, and it handles reflections automatically. Dynamic objects can receive GI but not contribute to it, and it only updates when the camera moves. It's also very runtime expensive, it's prone to light leaking, and especially prone to a type of artifacting where you can see the cascade shifting. In general, it tends not to do so well on flat, clear surfaces. I would say that it's good for scenes with plenty of texturing and visual interest to hide artifacting. You can use it for desktop games, but it's probably a good idea to include a game setting for disabling it. Efforts have also been made towards a new system to replace SDF GI. I'll of course include a link to the GitHub PR if you want to follow its progress. The next solution is Voxel GI, which as the name suggests is based on generating voxels. It does require baking, but I find that it's usually pretty quick. To add Voxel GI to our scene, we simply add a Voxel GI node. We position it and adjust the size to make it fit everything. Then we hit Bake Voxel GI and choose where we want to save our bake data. And that's it. And the cool thing is that it will instantly update to changes in our lighting. In general, Voxel GI is the most dynamic of the three solutions. We can also change the subdivisions of the grid that Voxel GI works on. We can see that visually here. When doing so, we need to hit Bake again. A higher subdivision results in more detailed lighting, but also comes with longer bake times and a runtime performance cost. So set this based on the hardware that you're targeting. And a lot of people don't know this, but we can actually go into the data resource created when baking and make further adjustments. I won't go into all the properties here since they're all really well documented, just hover over a property to see what it does. An awesome thing to note though is that any adjustments we make are immediately visible, no need to rebake. So using Voxel GI is pretty flexible, and it handles reflections automatically. The main drawbacks I've found is that it's still quite performance heavy, it's very prone to light leaking, and the result of the lighting is not super accurate. I'd say it's good for dynamic scenes where light leaking isn't an issue, such as outdoors. This is also fine for desktop games, but again, perhaps include a setting so the player can disable it. And if we have a look at our daytime scene, it actually lends itself well to both SDF and voxel-based GI, since light leaking probably isn't a problem, and there are plenty of textures to hide potential artifacting. So I tried both, and they did indeed look great with pretty much default settings. I even tried just using a single reflection probe, and the result wasn't too bad. You might find that it can be hard to preview the lighting of your scene with all the textures though. To see it better, we can always go to the top left of the scene view and set the display to lighting. In this case, it makes it much easier to see the difference between the techniques. But all of them actually have the same problem. There are currently multiple shadow casting street lamps in the scene, which is just not great for performance. So what if I told you that the final GI solution can pretty much eliminate the performance cost of these lights and at the same time produce the best looking lighting? Which brings us to Lightmap GI.
Lightmap GI works by pre-calculating the effects of all of the lighting in our scene
and baking it into textures called light maps. The light maps can then be overlaid on top of your level. This means that we can display extremely realistic lighting while costing almost no resources at runtime. But of course, because the light maps are essentially textures, they are completely static and won't react to changes in the scene. To get around this, it's common to only bake some of the lighting into light maps, and then have some real-time lights on top. Also, when baking light maps in Godot, it will automatically generate light map probes. These are a bit similar to reflection probes. They will calculate the lighting at a specific point, and then when playing the game, apply that lighting to dynamic objects. This helps moving objects blend in when it would otherwise be clear that they aren't light mapped. So how do we actually use this thing? Well, to bake a light map, all the meshes that we want to bake need to have a UV2 layer. This means that each mesh needs a set of texture coordinates that help map the geometry to the light map we're baking. And because we normally use the first UV map, UV1, for regular texturing, we refer to these as UV2s. Feeling confused? That's totally normal. UVs can be hard to unwrap your head around. Luckily, we don't have to create this second UV layer manually, though you could definitely do that if you want to in a program like Blender. Instead, we just tell Godot to generate them for us.
To see if a mesh has UV2s, we select it, go Mesh, View UV2s. In this case, the torus here doesn't have any. So to generate them, we go Mesh, Unwrap UV2 for light map. And now if we go to View the UV2s, we can see the UV map that Godot created. If you're working with imported models, such as this monkey here, we can do this more efficiently by selecting the model, going under Import, navigating to where it says Light Baking, and setting this to Static Light Maps. I'll re-import, and now if I go into the monkey here and select the mesh, go Mesh, View UV2, and again Godot has created a UV map for us, which makes us ready to bake light maps for our scene, which is actually very easy. We just add a Lightmap GI node, hit Bake Light Maps, and choose where we want to save our light map data. And that's it. Godot has now baked all of the lights and geometry that is on the same level or below in the hierarchy of the scene, which in this case is everything. But when I first did this, I couldn't actually see the monkey, because Godot went ahead and created so many light probes that it just looked black. Let me show you. If I go under View, Gizmos, and enable Lightmap GI, we can see just how many probes are in here. To reduce this number, we can go under Gen Probes, Subdivision, and decrease this a bit. And there's our monkey. But just to see what's going on, I'll disable the gizmos again. You can also see that Godot has created this data resource as well as this lightmap texture. Now, you can always toggle the lightmap on and off here. However, do note that if you're comparing this to other GI solutions, sometimes they won't display even though you toggle off the lightmap. In that case, we can select the lightmap, go under Data, and remove the light data resource. This will completely disable the lightmap. And of course, the data is still in the project, so to restore it, we can simply drag it back in. Now, most of the time, I actually think the default lightmap settings work quite well. If we zoom in on our monkey here, we can see clear red bounce light coming from the red wall on the left here onto the monkey, and blue bounce light spilling onto the right side of the monkey. But looking closer might also reveal a bit of weirdness. For example, we can see some hard edges here in the lighting. We can fix this pretty easily by selecting the monkey, going under the import settings and scrolling down to Lightmap Texel Size. A smaller value here will result in more precise light maps for this model, but the lightmap size and bake time will go up. I'm going to reduce this pretty drastically here just so you can see. Of course, we'll need to rebake, and immediately we can see a much smoother light map on the monkey, but we will also see it taking up more space on the light map. Another way to increase light quality, perhaps when doing a final bake, is by enabling super sampling on the lightmap node. This will bake the lightmap at a higher resolution and then downsample before saving, and I find that it works wonders. The result is often a much higher quality lightmap with smoother and more precise shadowing, less noise, and I found that it can even help combat light spilling from one part of the lightmap to another. This does take longer to bake, but because it gets downsampled, it shouldn't have a big effect on runtime performance. Because of this, I would always try to use super sampling before adjusting the texel scale, which increases the final lightmap resolution.
The quality setting is also fine to increase, but it adds a lot of time to baking and I rarely think it makes a big difference. So most of the time I leave it at medium or high. Enabling directional though can have a big impact, especially when baking static lights and for materials with normal maps. This includes directional information into the light map, which does come with longer bake times, larger light maps, and a small runtime cost. So Lightmap GI is definitely more work, but it produces the best results with the best performance. The main drawback is that the light maps are completely static, which makes it best for scenes with few moving elements, like the outdoor scene. Here the street lamps will stay in place, so I baked them into a light map. And immediately, the scene looked a lot better. I made sure to keep the sun marked as dynamic, this way objects moving through the scene would still clearly be affected by the interesting shadowing. And going back indoors, our tavern also has no moving elements, so I baked the lighting here as well. The only thing this limited a bit was that I'd like to have the light of the furnace flicker. I could have just not included this light in the light map, but I really liked the soft shadows that it produced. So as we're getting used to by now, I cheated. I baked the Omni light and then just added a spotlight on top. I disabled baking for it and added a looping animation. And that's it. I think both scenes look pretty good.
Of course, I have been staying out for a while now, and it's getting kind of dark.
So let's turn this scene into nighttime. Lighting nighttime is actually very similar to daytime. The main difference is that the artificial lights become much more important. First, I disabled GI, fog, and all the lights, and swapped out the sky texture with a nighttime one. I then turned the directional light into a moon by lining it up with the one visible in the sky, reducing the intensity, and giving it a more cool color. I re-enabled all the lamp lights, which were just fine to reuse, and with just those quick steps, we've turned our day into night. But I did feel that the scene lacked a little bit. I wanted it to feel more ominous. So again, I added the secret sauce. A slight fog based on height that lies near the ground, and a volumetric fog that fades into the distance. And this was fine, but I think the composition was a bit off. The scene needed something to really catch the eye. So, kind of like the green glow from the basement, I made one of the windows glow a bright blue. I added a spotlight that would shine through the fog, and then I used a neat trick, which is that you can actually add a texture to your light. So I created something that looked like the shape of the window, added it to the projector slot on the spotlight, and voila! It immediately gave the impression of a powerful light casting a window silhouette onto the ground. And with that, this scene was done. I don't know about you, but I think the difference is night and day. And just before we wrap up, I want to mention that the world environment has a few screen space effects that can easily be enabled. We didn't get to use them in these examples, but they might be good for your scenes. We have SSAO, which adds ambient occlusion. This darkens the part of the geometry that light has a hard time reaching, such as where two surfaces intersect. SSIL, which is made to be used together with one of the other GI solutions in order to create more accurate indirect lighting around small-scale details. And finally, SSR, which is another tool for adding reflections. It's especially good for close and detailed reflections, such as objects on a reflective floor.
Which brings us to the end of the video. Lighting is a huge topic, and there's of course a lot of things that we couldn't get into. Luckily, the documentation is pretty thorough on the many settings and has some good suggestions for further improving performance. The tavern used in this video is a slightly modified version of the fantasy game inn by this fantastic creator, and the outdoor medieval town is by this equally fantastic creator. I've repackaged both along with the project files for this video on GitHub under the CC attribution license, and there are of course links to the original creators as well. Also check out Zenva Academy and be among the first 50 people to grab 20% off your first year with the link below. Start building better Godot games today. And that pretty much concludes this video on lighting. But I can't seem to shake the feeling that we forgot something. Hello? Bird, you can come back now.